Hello friends, welcome to all of you in our class. In this lecture, we are going to see the point kinetics of enzyme catalyzed reactions. So before start our point, we have to know what are the enzymes and what are their characteristics. Enzymes means naturally occurred proteins. Okay, enzymes are naturally occurring proteins, or those proteins which occurred naturally are called as enzymes. Okay. Now let's see the kinetics of enzyme catalyzed reaction. For that purpose, we will get abbreviation E for enzyme, abbreviation S for substrate, S for substrate, and P for product. P for product and K for rate constant during the reaction. So when we add the substrate with enzyme, then we will get when we add substrate with enzyme, then we will get enzyme substrate complex. Enzyme substrate complex. This is unstable form, so, and this is activated form in this reaction, so I write here in square bracket. Okay, after this, decomposition of enzyme substrate complex form, and they will get product plus enzyme. Okay, so friends, see the first step. This is the activation step. So substrate reacts with enzyme, it will get the enzyme substrate complex. So this is the slow step in this reaction, so it will be reversible step. We are related to determination of kinetics of enzyme catalyzed reaction. So we need to write the rate constant for each and every step in the reaction. Okay, so first step is forward reaction step, second step is backward reaction step. So I write K1 for rate constant of first step, means K1 for rate constant of forward reaction step, and K minus 1 means rate constant for reversible or backward reaction of step first. Okay, this is the step first, and K2 for rate constant for second step, means in which step the enzyme substrate complex will decompose, and that step I write K2 as a rate constant. Okay, see careful this reaction. This is the first step, this is reversible step. Okay, this is the second step, and the nature of product or product forms in second step. So the amount or concentration of product should be depends on the enzyme substrate complex or concentration of enzyme substrate complex. So rate of reaction will be K2 into enzyme substrate complex or concentration of enzyme substrate complex. See here, this is the intermediate in reaction. Okay, this is not part of reactant, not part of product. So for this step, for the determination of rate of reaction, we need to calculate the concentration of enzyme substrate complex or the concentration of intermediate. So we will use steady state principle. So by using steady state principle, we can determine the concentration of enzyme substrate complex, and according to steady state principle, rate of formation of enzyme substrate complex or any intermediate will be equal to the rate of decomposition of intermediate, means here intermediate enzyme substrate complex. So rate of formation of enzyme substrate complex is equal to rate of decomposition of enzyme substrate complex. So for this step, we need to determine which steps are the rate formation and which steps are the decomposition of enzyme substrate complex. Again see this reaction. For observe first step is enzyme plus substrate plus enzyme. First step is forward step and gives enzyme substrate complex. Okay, so rate of formation of enzyme substrate complex will be equal to the rate of first step in the reaction, means K1 into concentration of E into concentration of S, means rate constant into concentration of the reactant. Okay, so I write here K1 into concentration of E into concentration of S is equal to rate of decomposition of enzyme substrate complex. So again you have to observe in which step enzyme substrate complex will decompose. Okay, so observe second step is also decomposition of enzyme substrate complex, and reversible of step of first step is also the decomposition of enzyme substrate complex. So collectively we can write K2 into concentration of enzyme substrate complex plus K minus 1 into concentration of enzyme substrate complex. Okay, this is the equation according to steady state principle. Now here this is the concentration of enzyme in the reaction. Okay, concentration of enzyme in the reaction, or which enzyme participate in the reaction. So the concentration of enzyme will be the summation, will be the total concentration of enzyme supply for the reaction and concentration of enzyme substrate complex. Okay, means concentration of enzyme is equal to the difference between total concentration supply for the reaction and those concentration or those amount of enzymes are involved in the actual formation of enzyme substrate complex, because the amount of product of formation it depends on the concentration of enzyme substrate complex, means how much amount of enzyme is involved in the reaction, and this is the how much amount of enzyme supply for the reaction. So by using difference between these two concepts we will get the actual amount of concentration of enzyme. Okay, E0 is the total concentration of enzyme in the reaction, Es is the concentration of enzyme involved in the reaction. So we can put this value in this relation. We will get K1 into concentration of enzyme, means E0 minus Es, okay, into concentration of S, concentration of S. I replace here E0 E by E0 minus Es, okay, is equal to same term, that is K2 into Es plus K minus 1 into Es. Okay, simplify this relation, we will get K1 into E0 into S minus K1 into Es into S is equal to K2 into Es plus K minus 1 into Es. Okay, now observe this relation. In this relation there are three terms in which concentration of Es is the common. So we can rearrange this relation as we can calculate concentration of enzyme substrate complex. So K1 into concentration of E0 into concentration of S is equal to, I will replace this term with on another side of the relation. So we will get K1 into Es into S plus K2 into Es plus K minus 1 into. So in right hand side equation there are three terms in which enzyme substrate complex term is common. So we can collect common term as Es into K1 into concentration of S plus K2 plus K minus 1. So from this relation we can determine the concentration of enzyme substrate complex, that is K1 into E0 into S divided by K1 into S plus K2 plus K minus 1. Okay, so this is the equation for concentration of enzyme substrate complex, and the value of enzyme substrate complex is depends on initial concentration or whole concentration supply for the reaction and the amount of substrate. So we can calculate rate of reaction, that is K. Rate of reaction is equal to K2 into concentration of enzyme substrate complex, which we have discussed before this term. Okay, so rate is equal to K2 into K1 into E0 into S divided by K1 into S plus K2 plus K minus 1. So we can divide the term K1 to both these relations. So we will get K2 into K1 upon K1 into E0 into S divided by K1 upon K1 into S plus K2 plus K minus 1 upon K1. So we will get the relation, that is K2 into concentration of E0 into concentration of S. So we will get rate is equal to K2 into concentration of E0 into concentration of S divided by concentration of S plus K2 plus K minus 1 upon K1. Okay, this is the rate equation for enzyme catalyzed reaction, and this study has already done by Michael and Menten. So this relation is nothing but, or this relation is called as Michael-Menten relation or Michael-Menten equation, and the term K2 plus K1, K2 plus K minus 1 divided by K1, that is this term is known as Michael constant. Okay, this is all about the kinetics of enzyme catalyzed reactions. Okay, I hope all of you clear about this point. Thank you.